Okay, number 14 is an example of a proof, or in other words, we need to justify each step. So sometimes it's a little trickier when they give us the left side. They give us all the work, and you'd think that'd be easier, but like if we combine like terms, it's easy to write, okay, I combine like terms. So we got to look at what they did on each step. So it says in the figure at the right, hi equals 5x. So I'm going to add that to my drawing. ij is 3x plus 12. And hj, from h to j, the whole thing, is 28. So their first step, they said hi plus ij equals hj. So they did not give a given step. How do they know that this segment plus this segment adds up to the total? How do we know these segments add up? It's the segment addition postulate. So that's how we know they add up. Next, we went from letters down to here, and now we have all numbers. How did that happen? Well, they took hi out, and if you look at hi, they put 5x in its place. So that is substitution. ij is 3x plus 12, and hj is 28. They substituted each one. And look, we're done with that geometry part. Now we're just down to algebra. How did they get the 8x? That's the question, because that's what's different. We have an 8x. They put 5x and 3x together, so they combined like terms. Or you could say they simplified that side of the equation. I would accept either answer. Okay, now we just have 8x on that side, and now we have 16 over here. Well, how did that happen? Well, if I look back, what would I do next? I would minus 12 and minus 12, and 28 minus 12 is 16. That cancels out. That means they must have used the subtraction property. Okay? And the next step will be to divide both by 8. So this is the division property, and that's x equals 2. The final step, you got hi equals 5 times 2. Well, what they did is they solved for hi. They substituted in that equals 10. So they just did 5 times our x, which was 2, equals 10. So they actually did two things here. I would accept either simplify or I would accept substitution because you substituted these numbers in.